All right, I hopped over to 2017 number 4 because it's also a 4-point problem, so you can do 7 and 4 together. 2016 number 7 and then 2017 number 4. Make that your 15 minutes for one day. This is a fun little blast from the past, a little chromatography question, which is fun, right? Finding the dyes of the M&Ms. Red 40 and blue 1 and yellow 5. And so when we look at this thing, they give us 3 dyes that they dropped onto the paper, and they gave us an unknown, and we have some kind of nonpolar solvent, and we're letting the dyes run. And then this is after the dyes have run, when you come back in the next day, and you're looking at after those dyes have run, and what are the results of those things. So that's what's happening here. It tells us this is the important part. Chromatography is all about polarity. And so we have a nonpolar solution, and we have a polar material. That means the chromatography paper is polar. And so it's asking us which dye is the least polar. Justify your answer in terms of interaction between the dyes and the solvent, or between the dyes and the paper. Either one. And so here's the deal. If something's nonpolar, it's going to be attracted to the solvent, right? Because that's what it's going to dissolve in, and so it's going to move where the solvent moves. If something is polar, then it's going to be attracted to the paper, and it is not going to move nearly as far because it's going to be stuck to the paper rather than stuck to the solution. So when we look at this thing, which dye is the least polar? The nonpolar solvent, dye C, traveled the farthest with that nonpolar solvent. So the answer is dye C is least polar because nonpolar dyes would be most attracted to nonpolar solvents and travel the farthest. So I explained it this way. Dye C is least polar because nonpolar dyes be most attracted to nonpolar solvent and travel the farthest. Or you could put dye C because nonpolar dyes are least strongly attracted to the polar chromatography paper. So it gave you an either or option here between the dyes and the solvent, or the dyes and the paper. So you could say dye C because it's nonpolar like the solvent, or dye C because dye C is nonpolar and the paper is polar, and so it travels the farthest because it's not attracted to the paper. Good. And then it says in B, which dye is present in the unknown sample? Identify your answer. So we have an unknown sample that runs on the right side of these things, and what you notice is that the unknown sample runs about halfway as far as the solvent. Good. And when you look at the paper with the dyes A, B, and C, we are then looking for the dye that travels about half as far as the solvent. And so the dye here in the unknown is going to be dye A. And so for B, on the problem, the unknown is the dye A. And you guys are familiar with retention factors, so you can say because the RF value, the retention factor, is about 0.5 for the unknown and for dye A. If you can't remember retention factor, that is a little blast from the past. It's been a year since you've seen that. You can say the unknown is die A because it runs proportionally to the solvent, the same as the unknown runs proportionally to the solvent. The distance it traveled versus the solvent front is what they call it here. That's it. A short, quick one, but kind of a fun one to look back on.